Hello, my name is Amarjeet Badave, and currently I'm pursuing my bachelor's in electrical engineering from Sharad Institute of Technology, College of Engineering. Under Emertxe Information Technology, I have completed my internship on the topic of home automation. So it is my some of the content from my projects. First of all, I'm completing my programming in embedded C programming language, and afterwards I will just introduce with embedded systems, and afterwards Internet of Things, and at the end I will tell you about what is my project requirements, and I will show also what is my how exactly my project should look like and how does it works. So first of all, in C programming, which things I have learned, I just explain here. So first of all, in the data types, we are learning some data types like right integer with integer and characters, float, double. It is some kind of data types which is required to tell the compiler or to the computer about what exactly the size required for this the any kind of data. So afterwards, I learning some conditional constructs like if else. If we require only one condition, then we need to use this if condition, and if we require two conditions like if either it is true or false, so at that time we need to require if else conditions. So afterwards, else if is same opposite of if else, and in particular case, or if we require only particular function or any particular task among the all, so at that time we need to require some switch case where just one condition is executes among the all, and afterwards we are going to looping statements, which is for loop, while loop, and do while loop. If we require three if we require three things in a one condition, like at the initialization some condition, and at then increment or decrement, at that time we need to require for loop. And if you want just it is condition true or false, at that time at the starting it checks in a while loop. If the condition is true, then and then only it will execute the furthermore brackets. And if you require do while loop, it is at the starting it is not check the condition, at the ending it will check the condition. So in this case, it automatically by default run at least one our whole program in the do while loop. Afterwards, we are using some operators like assignment operators and bitwise operator, like that, on working on only one or two operands. Afterwards, it is an array. It is a collection of data types of or similar data types where we can store either all the characters instead of one or two. If you require large number of amount of data, then at that time we are using arrays. And afterwards, functions and pointers. It is also pass by value function, or pass by a reference. Or also I have learned your basics of pointers. It is shows the location. Pointer means it is just basic the show the location or the location of the variable where it is stored in the memory. Also I am learning here strings. It is a defined string, string initialization, passing string to the function. This kind of stuff I am learning here. Also, there are storage classes and pre-processing like hash include and that all. So afterwards, I'm coming with to the embedded systems. It is a definition of embedded system. It is any combination of hardware and software which will combine, or which is intended to do a specific task, can be called as embedded system, right? So embedded system we can also, it is the basic thing. For example, it is a washing machine where we are using some hardware, some processors, and there I have used some programming also to run the machine at a particular time, and that all. It is the best example of embedded system. So here are some components it is required for embedded system, like software. Mostly the C or C++ programming languages or embedded C programming languages is used in embedded systems. So there are some actuators. Their output is also in the form of digital, either it is digital or analogous, right? So analogous means it is vary from 0 to 5 volt or 0 to 12 volt in between. In digital means it is either 1 or 2. It is also there are some another names also, it is true or false or high or low. This kind of stuff is in the digital signals. So we are using here some actuators, and if there is output is in the analog, then we need to convert some digital to uh, it is we need to convert some analog to digital. So here we also required some converters also. Some sensors we are using interfaces, some sensors by using some ADC, which is convert also analog to digital conversion. And sensors also we require some power source to provide this kind of embedded system, either it is battery or our conventional power source. And also there are some controller, processor or system on a chip. It is also required memory to store our data, and also diagnostic ports, human interfaces. Interfacing are also different part, and it is a large part of embedded system. There are lots of different stuff in the interfaces also. We need to first of all give some priorities and dependent on, we require that kind of interface. And also there are some communication protocols required in embedded system like I2C or UHART, like that. So it is just basics about embedded system. So right now I'm moving towards the Internet of Things. So first, the basic definition of Internet of Things is the network of physical objects that contain embedded technology, right, to communicate and interact with their internal states or the external environment. It is also just basic. First of all, we need to establish some embedded system. It is a hardware and software. After, by the using some advanced technology like cloud computing and that all, we just connect with it to the wireless network media or some wired network media to the, and we store our whole data to the internet for getting some uh, future, or we required some future, right? So in at that time we use this kind of data or historical data we required to predict the what is exactly happening in the future. So in this way we can using Internet of Things. And uh, right now in the industry 4.0 there is lots of usage of Internet of Things, so I'm also interested to learn this, so that's why I have completed this internship. So what is the background of Internet of Things? Or I will just briefly explain about what exactly it is. It is the collecting information from lots of devices. It's cool, but it's just telemetric, right? So merging perspectives between devices, system, and humans to build a better understanding to the world around us. It is the main purpose of Internet of Things. So right now I'm going to the what it is exactly like. It is a unique object connected to the internet, or it is a particular object we require to interface with the internet to store our data, right? So devices, it is not a people. It is bidirectional communication. It also sent to the our embedded hardware from the internet also by putting some limitations or by putting some limits afterwards. We can get also feedback from the internet also. So that's why we are calling here bidirectional communication. And as you know already, we can store our data to the internet also, right? So it is a large and complex data flows. It is new types of insights. So why it is important? So there are 13.8 billion IoT devices in the world today, right? Outnumbering is the global population almost by twice. So the worldwide government Internet of Things endpoint electronics and communication market with total 21.3 billion. It is just the prediction, right? In 2022, but according to Gartner, this is 22% increase from a forecast total of 17.5 billion in 2021. So it is more than 5 billion increasing in the market of Internet of Things. So it is also leading industry examples like utilities, we need to electricity, and everywhere it is right now smart grid are using. So with there we just required for Internet of Things. Also there are insurance, agriculture. So you know also drones are largely used nowadays in the agriculture sector. Also factory, automobiles, transport, consumers. Also in the transport or automobiles, it largely use embedded system and Internet of Things right now in our advanced vehicles. So it is just architecture of overview of IoT. There are three mainly layers. First of all, device connectivity, where we just need to our sensors or actuators connected through the cloud gateway either or cloud gateway, right? So data processing analytics is happen in the IoT solution backend. There are some programming languages, another programming languages are used to the just process on this collecting data from different loads or sources. So at the end, it is a presentation layer. Presentation and business connectivity is the just show of what exactly is we are getting data or in the some kind of perfect or particular format we are presenting here that all data. So here are some general technical requirements. With many devices, large scale security requirements, volume of data are largely increased nowadays. End-to-end integration. Also, I'm going to explain here. And right now, I'm coming to my project. What exactly it is? So first of all, I'm using some here. Which kind of contents I'm using in my project. I will just briefly explain about it. So LED and temperature sensor, LDR, serial tank, for serial communication, Ethernet shield, Blink IoT app, Arduino ID for programming, fixing lab for just integration of different components, right? So basically, first of all, what is LED? So first of all, I will explain what exactly is LED, but right now I'm just use which kind of tools I'm using here. So it is, first of all, I'm using Arduino ID just for programming, and afterwards Pixim Lab for integrating different devices, and it is a Blink IoT app which is control our whole program throughout the wireless technology, like from our mobile also. So we can remotely manage our connected electronic device at any scale, from personal IoT project to millions of commercial connected products, right? So I will just show you about how exactly it look like. I'm coming to the my first part. It is the light emitting diodes, right? I'm using here garden lights or LED for garden purpose, which is required in our home. So LED is the simplest device used in the most of the embedded application as a feedback or just a blinking purpose. Works just like diodes. It is exactly working same like as a diode. So low energy consumption, longer life, small size, faster switching mate. It is usable in wide applications. It is also some uh, advantages also for using this LED. So it is mostly used in home lighting, remote controls, surveillance purpose, under security, displays, and many more. So how it is exactly interface with the LED with the Arduino, I have just explained here. So I will also just to show you about how exactly it look like and my program for LED. So here is my program. So I am using here LDR to control our LED lights. So I am just here explain my programming in the just a briefly I will explain here. So here are garden lights. I am naming as a garden light, or I am giving is a pin number 3 as digital. It is the digital input output pin. So where I am using 3 as a digital pin. Here is some program for I am first of all I am initialization garden light as a output, and I'm reading some input from the analog read using analog read function from the LDR, and once the LDR sends or gives the output, and accordingly that I have using here I'm controlling here my LED. So LDR is work on the principle of sunrise, or when we get sunrise from the sun at a morning, when the intensity of sunrise or sun rays are increases, then the decrease in the resistance of LDR. But here we are exactly doing reverse mapping to convert our values in the programming languages. So when the resistance is less, then we are also giving 0 as input to the our LED, and once at the evening when sunset is happening at that time, we just need to so automatically resistance is increases from the LDR, and we also doing here programming in the reverse manner, like at the evening we just need to glow our LED lights or our garden lights. So that's purpose I am using here this reverse mapping. So here I am just converting 1023, it is a binary value for the highest value to the digital input, and I have divided it by 4 to just convert it into 255. So in this way I have just, and here at the end I am giving this kind of garden light as an input value, which is I have measured here by using this formula, and afterwards I'm just giving a delay to stay my LEDs glow. Here also header file I'm including, just I'm giving uh, LDR sensor as I'm taking as a analog output, which is I am connected to the A1 pin. So it's just basic of the LDR, and afterwards I'm come to the my PPD, and I'm here. So second I am using here CLCD, which is also mostly commonly used display for the ASCII characters. Some customization and symbol also is possible if you required or if you read the data sheets. So I am here using in the CLCD provides two communication modes, either it is 8-bit mode or 4-bit mode. I am using here I2C protocol or I2C interface. So where I just required some only one or I just required for two connections, and I will also show you about it how it like exactly look likes in my programming, or it is I am connected with my PiximLab ID. I will just to show you how I connected these all things. So in the spare parts I have connected this. I will just to show about my connections also. So in the connection I have joined my serial clock connection to the analog input as a A5, and also digital signal to the A4. It is the serial data, so it is connected to the pin number A4, and it is serial clock. It is connected to the A5. By using this I2C, I am writing some programs on the CLCD. Also, I'm using here heater system, and it is the Ethernet shell, and also it is the LDR where I will control my brightness of the LED from this LDR. So once I connected it through the internet, I will show you exactly how it look like. And here are my the garden lights. So it's just about CLCD, and right now I am going to display about how exactly interface is CLCD is happening here. Afterwards, I will just show you the basics of what is pulse width modulation, right? It is the best, or it is the conversion of analog pins into the digital, and how exactly look like the PMW. I will just explain about briefly about it, how it exactly works. So sometimes it is also called as pulse duration modulation, a technique used to vary the active time versus inactive time in a fixed period, mostly used to control the average voltage of the load connected, and used in wide application like motor control, lamp dimmers, audio, power control, and many more. I will just go with, and how exactly it look like. It is the waveform for PMW. It is a T on period and it is T off period. We can control by either increasing T on period or T off period. It is also serial time. I will just show you how it is also exactly working. I have connected to it is a port 1 and it is the port 2 in my Arduino, and in this way we are controlling this tank throughout our mobile. So it's just basic. So now right now I am working towards my exactly project model. It is my connection. I will just show you about it. Is I am here. Heater is connected to the pin number 5, digital pin number 5, and cooler is connected to 4. It is also I'm connected on virtual on the Blink IoT app, and I'm going to control these all peripherals from the my Blink IoT. It is LDR and it is the Ethernet shield, and I'm also show you about how exactly serial remote tank 6 works. So just I need to connect it from COM number 2 because I have already connected my Arduino to the COM number 1, port number 1. So I'm connecting here. So, and I will briefly explain about my project, and afterwards I will, it is my main file from my programming. So first of all, I am using here some of the hidden libraries like Ethernet.h, Sky.h, Blink Simple Ethernet.h, Wire.h, Liquid Crystal I2C for the protocol I am using here. This is the main function, and I am divided my project in the some another function like serial tank. In the serial tank, I have used some functions like enable inlet, disable inlet, enable outlet, disable outlet, and using the serial write, I'm just showing on the CLCD. And also there are I'm using a temperature system. In that temperature, I'm using some functions like read temperature, cooler control, and heater control. By using this, we can just turn on and turn off the temperature. And I already explained about the CLCD. So right now, I'm just going to here compile my code and get a binary file by using export compile binary. And once I get this hex file, I just upload it on my PiximLab ID in the Arduino. And once it get compiled, I will show you how it exactly works. So here is my compiling is happening. Once it complete, and that all header files I have collected here at the main program. You can see here by using blink right, enable inlet, enable output. I'm using these functions. Also handle temperature, and I'm putting here some conditions like if my temperature is increased than 35 degrees, then automatically turn off the heater. And again, same provision I have provided in the water tank also. If my volume of water is less than 2000, then automatically turn on the inlet valve. So here I am checking these two conditions, and afterwards I'm Also, I'm sending some notifications like blink terminal, and if the water is less than 2000, then it will we need to show on our mobile screen also. So here are some, it is the just the basics of programming. So I'm going to show about how exactly I can control it on the blink IoT app. First of all, I have compilation is already done. I'm going to just load my compiled file. So here is my compiled file. I'm going to open it right now, and I will show you exactly how it's everything is works. So here is my tank. Now once compilation is done, then it will start filling this tank. Also, I will show you about how I can control it on my mobile app. So it is, you can show here as the tank is filling up, it will show the volume of water here, and it is the just basic I'm showing here. Inlet flow is on, right. So inlet wall is also on. That's why you're showing the on inlet is flow on. So once it's filled, it will just show notification on our mobile. I will show how it look like. Once it's full, then inlet wall is automatically off, right. So volume is 3000 liter. So right now I will show you how everything will look like and how we can control throughout our mobile. So right now I am opening here my blink IoT application, and I will show you how it look like and how I can control this home automation by using this blink IoT app. So here are my programming, and here is my interfacing. So you can see here I'm opening here my blink IoT application. It is my project on the home automation. So I will control it. Okay, so here is my cooler is also off. My heater is also off. It is constant 27 by 334. So I will just on my heater by using my mobile. So once my temperature, you can see here, slowly it will increase the temperature of heater. And once it is increasing, and you can show here heater is on. And once heater is temperature is beyond the 35 degrees Celsius, it is automatically stop, or it will automatically turn off the heater. You can see here my temperature is about 37 degree, and it automatically heater is turned off, right. In this way we can control our heater or our room temperature by using our blink IoT mobile app. Also I will show you cooler, and if my temperature is, I want to reduce my temperature, I just turn on my cooler. You can see here that once it is get notification, right, like cooler is turn on, then my cooler fan is also starts rotating. You can see here. Also I can turn off the cooler from my mobile, and I'm getting here my all notifications. In this same manner, I'm going to here tab 2. So here you can see it is the inlet wall, it is the outlet wall. My volume of water is 3000 liter. I just want to turn on my outlet wall from mobile. Once I turn on the outlet wall, you can see here the notification like turn on the outlet wall and my water is drain out here. And I'm setting the condition like if my water volume is less than 2000, then it automatically turn on the inlet wall. So you can see here my water is decreasing right now, and when once it gets less than 2000, then automatically my notification is also pop up, your water level is less than 200 2000, and I'm going to turning on the inlet wall, right? So you can see here, and it is not increasing because my outlet is on, or we are using my water for the further uses. So I just going to turn off the my outlet wall from my mobile screen. Also you can see here I have turned off my outlet wall. So once it's turned off, it will start reducing again, right? So in this manner or in this way we can control our cereal tank or our heater, cooler, and also this all kind of requirements I have completed here. I will again show you how exactly my LDR is also working. So once I will show you my LDR is dependent on the how exactly you can see here the intensity of LDR is reducing slowly. So once I reduce, you can see here once I increase the this tab or this potentiometer, then it will increase the intensity also, right? So in this way, I'm come to the end, and it is just my project. So first of all, I would like to say also thank you to the Emerge Information Technology to give me this opportunity. So thank you so much. Thank you.